Okay, hi guys. So let's take some more examples on the comparison of SN1, SN2, E1 and E2 reactions. Okay, so let us say we have something like this. We have a matrix. Okay, in that matrix we have something like this compound. Okay, first let me write down the left column or right column. So W here signifies it's a nucleophilic substitution reaction. X signifies it's a elimination reaction. Y signifies this is the reacts with sodium to evolve hydrogen gas. Finally Z we have it's a example of addition reaction. Okay, now let's draw the left column. We have this compound, we have this compound. So you have to just tell out of out of this compound you have to match these compounds with these all right columns. There can be many to many mappings. We have something like this, and finally fourth one we have something like this CH2OH here. Okay, so what would be the mappings? So for the first part we would be having W and X. Why? Nucleophilic substitution reaction can happen in this case. Elimination reaction can also happen in in this case if appropriate reagents are used. In the second case, uh, elimination reaction cannot take place. Addition reaction can also not take place because we have the aromatic benzene ring, and in normal conditions we have to apply high pressure high temperature conditions in order to break the pi bonds and the aromaticity of the ring for this to show addition reaction. So in normal circumstances we are taking this, that Z would not be the case here. So elimination also cannot take place because we don't have any alpha hydrogen here which can donate hydrogen to which can remove hydrogen atom from itself. Okay, so we'd have only substitution reaction or W. Okay, for this case we can have nucleophilic substitution reaction, we can have elimination reaction. It will also react with hydrogen to evolve it will also react with sodium to evolve hydrogen gas because it's a OH group here. Okay, then for this case again we cannot have any we can actually have substitution, and we can have the reaction with hydrogen evolving to evolve reaction with sodium to evolve hydrogen gas. Okay, so let's look at what is now called as Schwarz reaction. Schwarz reaction. Okay, so what happens is we have something like this and AgF as a reagent. So what happens is we get CS3F as the product. Okay, so the mechanism is pretty straightforward. It undergoes SN2 mechanism. Okay, with that said, F minus will actually attack on CS3 from backside, and Br will actually Br and C bond will actually break, and Br will take all the bond electrons. So we'll have CH3F, and Br will associate itself with Ag to form AgBr. Okay, so now let us take another topic. We have Grignard reagent. So what is Grignard reagent? We have something known as RMgX is known as Grignard reagent. Okay, let us take look into the preparation of Grignard reagent. The preparation is like this. In the first step, we have something like a halogen RBr. We react it with magnesium in presence of ether. So what happens is we have something like R gets a partial negative charge, Mg gets a partial positive charge, and Br associates itself with Mg. Okay, so this is a example of organometallic compound. Okay, okay. Similarly, if we have this pH Br presence of Mg ether, we will have something like pH Mg Br, partial charge negative again on the carbon atom of phenyl ring. Again this is a high yield reaction. Okay, so let's talk about the know-hows of it, or the mechanism involved in getting this compound, right? So we have in the first step RBr, and the rate determining step for this is formation of R dot, and obviously Mg dot and Br dot. Okay, so now these actually come together to form a bond. So RMgBr will be formed with a partial charge negative on R. So hence our Grignard reagent is formed. Okay, so let's talk about the solvent also before ending this lecture. So solvent which can be used in the preparation of Grignard reagent can be ETO, this is ether, or we can have tetrahydrofuran, THF, or we can have something like this, which is dioxone. Okay, so with this we come to an end of this lecture. We'll meet you in the next lecture. Till then, good luck and goodbye.